Alright, welcome. Let's take this question on equilibrium of fluids. It's a WAEC question, WASSCE. It says a uniform cylindrical hydrometer of mass 20 grams and cross-sectional area 0.54 cm square floats upright in a liquid. If 25 cm of its length is submerged, calculate the relative density of the liquid. Density of water equals to 1 gram per cm cube. Okay, so let's quickly do this. Now, before we start, we don't just jump into calculations. First, I'll try to sketch the scenario to have a proper understanding what we are being asked and what I should do. So to sketch this scenario, now they say that a uniform cylindrical hydrometer floats upright in a liquid. So I will try to sketch a cylindrical hydrometer, something like this, cylinder, upright. It floats upright in a liquid. So let's say this is the liquid. This looks like a barometer, but anyway, just for the illustration. So in a liquid that we don't really know the name of the liquid, so this is it, and its cross-sectional area, what we mean is this area, this circular area, cross-sectional area, is given as what? Is given as 0.54 cm square, and then we are told that 25 cm of its length is submerged. That means from here to here is 25 cm. That's the length that has been submerged. So we have to calculate the relative density of this liquid, not the hydrometer. Alright, so let's proceed. Now, first we have to define relative density. Relative density is defined as what? Density of a substance, in this case of that liquid, over density of water. So there are other alternative definition of relative density, but the main point about the definition is that whatever it is on the numerator, it has to be compared with water. Relative density simply means comparing the mass, weight, or density of a substance to equal to that of water. That's equal parameter of water. Okay, so we proceed. So relative density is density of that liquid over density of water, and density of the liquid can be defined as, or density of any substance can be defined as what? The mass of that substance over the volume of that substance. However, we don't know the mass of this liquid. Here we were only told about the mass of the cylinder that is on the liquid. So what do we do? Now, you remember principles of flotation or law of flotation. It says that a body will float if its weight is equal to what? The upthrust. Now, what is upthrust? Upthrust is an upward force that acts on a body that is inside a fluid, that is partially or totally submerged in a fluid. Now, a body's one, you notice that whenever you submerge any material or anything inside water, the weight of that material reduces. Now, the weight reduces because there's an upward force. There's an upward force acting on that material from the liquid or from the fluid in which it is. So that's what we call what? Upthrust. So principle of flotation says that if a body is floating, it means that that upward force from the liquid called upthrust is equal to what? The weight of that body. So, and the weight of a body is given as what? The mass of that body times acceleration due to gravity. And upthrust is also defined mathematically as what? Density of a liquid times the volume of that liquid times acceleration due to gravity. Now, acceleration due to gravity is the same. They will cancel each other. So you then find out that if you make density of the liquid the subject of the formula, that means density of the liquid will be given as what? The mass of that cylinder over the volume of the cylinder that is being submerged. So the volume that we are using to calculate, and you know that a volume is defined as what? Area times what? Height. So we have been given the area here, and we've been given the height, 25 cm. So it's easy to calculate the volume. We are not using the volume of the entire cylinder. We are only using the volume of the part that has been submerged, because it is the part that has been submerged that have displaced the liquid. Principle of Archimedes' principle states that when a body is wholly or partially immersed in a fluid, that it experiences an upthrust which equals to the weight of the fluid displaced. So we are still saying the same thing. So now let's calculate the density of the liquid. So density of the liquid will be equals to, we have to first calculate this density of the liquid, then later we substitute it to find the relative density of that liquid by comparing it with that of water. So mass is 20 grams, and we are going to convert that 20 grams to kilogram by dividing it by 1000, which is the same thing as writing it as what? 20 times 10 raised to the power of minus 3. That's 20 grams. To convert it to kilogram, you have to divide it by 1000. And then this 1000 is the same thing as 10 raised to the power of 3. And when you take it to the numerator, it's the same thing as what? 20 times 10 raised to the power minus 3. Okay, so that's the mass divided by volume. Volume in this case is area times the height. So the area is 0.54 cm. That cm, we have to convert it to meter, because we have converted the mass to the standard unit in physics, which is kilogram. So the area we have to convert it to the standard unit in physics, which is meter. So this will be 0.5 cm. So to convert it to meter, we multiply it by 10 raised to the power minus 2. Cm means centimeter means 10 raised to the power what? Minus 2. But however, we are going to square this 10 raised to the power minus 2 because it is cm squared. Cm squared. That means you square whatever you have here. You square whatever you have there. Okay, excuse me. Let me move this thing up so I have space to write. Okay. So that's then times the height. The height we were given is 25 cm. So 25, the cm, there, to convert it to meter, that's times 10 raised to the power minus 2. We don't need to double this one because it's not cm squared. If you need more understanding on unit conversion, you can book a session with me for an online class. So we run it through and make you understand it, the conversion, so easy. Okay. So now, 0 point, this is how I'm going to do this. I won't just input everything in a calculator, because sometimes you don't know the kind of exam you see this sort of workings. Sometimes it is exam that they give you on screen calculator that is unable to perform complex fractions. So if I was with a simple calculator, this is what I would do. I'll do 0.54 times 25. Let's maintain my 20 times 10 raised to the power minus 3. Okay, 0.54 times 25. That would be 13.5. Then times, this is 10 raised to the power of minus 4 from here, law of indices, times this 10 raised to the power of minus 2. Alright. Then with my simple calculator, I'll still do 20 divided by 13.5. That will give me 1.48, approximately 1.48. The rest are recurring decimal. Then times 10 raised to power of what? If this 10 raised to power minus 4 comes to the numerator, it becomes, okay, here is minus 3. This will be 10 raised to power minus, okay, let me not waste so much time covering space. So law of indices is minus 4. When it comes there, it becomes plus 4. And minus 2, when it comes there, it becomes plus 2. So in the end, you are having 1.48 times 10 raised to power of that minus that is 10 raised to power of 3. 10 raised to power of 3 kilogram per meter cube. This my meter is funny. Okay, so now we've gotten the density of the liquid. So now what is left is the relative density. Now relative density is density of that liquid over density of water, and we're given a density of water to be 1 gram per cm cube, 1 gram per cm cube, which is the same thing as 1000 kilogram per meter cube. If you still want understanding on how to do this conversion, you can book a session with me and we explain it in depth. Okay, so if you substitute that here, relative density will be equals to 1.48 times 10 raised to power of 3 divided by what? Divided by 1000, which is the same thing as 10 raised to power of 3. So this will cancel this. So relative density of that liquid equals to what? 1.48. All right, thank you.